In this unit, we're going to start talking about strings. And you can imagine, as we have one entire unit dedicated to string, is because they are a pretty important topic. As we told you in the data types unit or lesson, strings are different from Python 2 to Python 3. They are actually a completely different data type. Thankfully, that difference isn't that evident when you're just using them. When if you're having a standard usage, Python 2 and Python 3 should behave pretty much in the same way. There will be difference though, and you should be aware of that. If you're using Python 3, which is the recommended version, you will not have many problems. If you're using Python 2, you have to be careful because, for example, these type of special characters will not be available. So again, if you're using Python 3, you're pretty much safe. If you're using Python 2, you should be a little bit more careful. We encourage you to take a look at both documentations for Python 2 and 3 and to compare them, but you will see that they are pretty much the same. So let's get started. How do you create a string? You use it, you know it already. You will use quotes, right, to surround that given word, that given text that you want to express. You can use either double quotes or single quotes. It's pretty much the same thing. Python doesn't care about that. It will be important to introduce the concept of literal versus programmatic things or creation of things. So this is a literal way of expressing a piece of text. We're just literally writing what we want to see. We're writing the characters that we want to see out. This isn't so common in programming. Strings are the number one case, the first case you will see as any literal creation mechanism, but this is not something that is going to happen too often, and it's important to understand when it's happening, and of course later you will understand why it's happening. But it's important, right? We're not just doing any black magic to get this string out, and even though the computer doesn't know much about English, about characters, we're just expressing these, and the computer is able to parse it and understand what we're trying to say, right? Again, this might not sound so important or special to you, but it's a special thing. We can also create strings programmatically. For example, I could start with an empty string, and then I could add a few characters after I created something like in this way. Hello, I'm just gonna put 2 characters here, hello world, and finally print the message again. So in this case, I've used a programmatic mechanism to create the string, not something so literal as this. And we could even go deeper, because underneath these things are gonna be expressed as bytes, as ones and zeros, bits, right? So I could have expressed the bits that could encode this character, and it can get a little bit more complicated. No need to go that way right now. What you wanna know here is that we're using a literal approach to create these strings, and we will see this literal approach in other data types, like for example collections. Something else that you need to know is that strings have a bunch of really useful mechanisms to work with them, right? So for example, lower, split, title, all these methods are documented right here. So you can just check them all later and see what's that method you're looking in when you're trying to solve a given issue. So for example, you need a string in lowercase. I'm just gonna show you all examples here. You need a string in lowercase, right? And we start with this. Python is awesome example for everything. You should use the .lower method, and that will turn that given string all into lowercase. So for example, the P and the A, these characters right here are converted back to their lowercase representation. I don't know, something like split. Let's split a given string by a given character. So Python will find, and let me put it here separately for you. I'm gonna put these dot split, and maybe you don't see it, but here I'm gonna put a white space, right? So there is an empty character here. So Python will find every occurrence of that white space, like here or here, and it will just split that string into all those chunks, right? The result in this case is gonna be a list, which is a type of collection that we're gonna see in future sections. Should be pretty intuitive, right? So for example, title, given a string, a simple string like ASD, for example, if you use the title method, right, that will give you each character as a title version, right? So if you put, for example, A, B, C, D, E, F, G, H, something like that, every first character is gonna be capitalized for it to be a title, right? So again, all these methods are a handful useful methods you have available for each one of the strings. You can remove parts of the string, etc. You have a few that are a little bit more interesting. For example, replacing things, right? You can replace a given word by other words. So let me get this string first here. And then we're gonna replace awesome with amazing. So Python is searching for this given word first, right? And if it can find it, it will be replacing it with that other one. Important, all these methods are immutable. That means that we're never changing the original string. We are creating a new string. So let me use an example here, and what I will do is something like print message.lower, for example. And again, this method, what it's doing, it's turning the original string to lowercase. But that doesn't mean that it's affecting the original one. This one, if I print it again, I'm gonna print a few separators here, and then I'm gonna print message again. What you will see, if it runs, there you go, is that the original one is still, right, with capitals in the beginning. So it's not changing it. There is actually no way to change a string once it's created. There is no way at all right? Strings are immutable, and this is a really important concept and a really cool feature of the Python programming language, because that's safe. If we cannot be changing things around, we have a known state in our app. Whenever we create a string, we know that it will be that string forever, and there is no way of changing it. And that's pretty safe. It makes you feel safe and comfortable. So what happens if we do, for example, something like message equals message.lower, right? What's happening right there? I will print message now. I don't need this anymore. And now it seems like message was changed. But actually what happened was that we just created a different, we just reassigned the message variable to a different string. This string is still unchanged. And what I'm gonna do is I'm gonna create a simple alias for this string, like one of these labels that we use, a variable. So I'm gonna use alias message to point to message, right? So then I will change this variable to point it to this new string, and then you will see that alias message is still pointing to the original one. Let me show you the graphical representation of this. So for this example, what we will do is just picture our memory as we usually do. And here we're gonna also separate it like in these variables versus values part, right? So in our previous example, what we were doing was we were creating two different strings, two different values. Like here we had hello world with the H and W capitalized, and then we're turning it into a lowercase representation of that. So here we start with a given value, which is hello world with capital hello world. There you go. It says world there. And we are pointing a variable to that. I'm just gonna call it M from message, right? Pointing it back to that given string, right? This is a value string. So then what we do is we evoke the method message.lower. But again, remember that this thing is immutable. It's actually creating a new value. So let's split this operation, remember, into two operations. The right hand side of the operation and the left side, which is just the assignment. So I'm gonna focus in this part. What happens here? Python is actually creating a new string here. I'm going to put it below, which is again hello world, all in lowercase, right? So this is just a lowercase representation of that string. And then what it's doing, the second part, is just assigning that given variable, right? This m variable, it's just reassigning it, so it's killing this reference and it's creating a new one back here. So it seems, for us, at least it seems that the string was changed, but it was never changed. Now it's the original one, the original string is still here, it's still floating in memory. So it's pretty much lost if we don't create the alias, but it's not changed. That's an important thing. A new one was created and this variable was just pointed back to that. So what we did before was, before removing this reference, we created another one, the alias, that pointed right here. So when we created the lower and we assigned the value, right, this left side of the operation, what we ended up doing is just, again, killing this reference and creating a new one here. But this original reference still points to the original string. So that's why you can see the original one with capital characters at the beginning. Important takeaway, strings are immutable, all right? You will never be able to change them, and that's a good thing, that's a great thing. It's something that provides safety for our program. So finally, remember to check the documentation. All the useful methods you have for strings, they're all documented, and we have a few examples here if you want to keep checking them out. In this lesson, we're going to start talking about string slicing and string indexing, which is a really important concept because you will also see a parallelism when working with lists and other types of collections. So basically what happens is whenever you create a string in Python, Python is assigning a given number, a given numeric index to each one of the characters in your string. So basically a string for Python is just a sequence of characters, one after the other. We don't realize it, but Python again is just keeping them as a sequence and it's assigning a numeric index to each one of the characters in this string. These indexes will start counting from the position 0. There's no way to change this. So the first character in your string will always be the one in the index 0. You can access individual characters in your string by using that numeric position. So for example, if you want to access the first character, you will be using the position 0. How do you do it in code? Well, you will just reference that given string, for example, with a variable. In this case, the string is going to be called s, the variable in our example. And we're using square brackets and just putting the position, the index, right, between those brackets. So in this case, is a character in the position 0, basically the first character. We can also get the second character, right, which is the one in position 1. It's the second position 1 because again, we're starting to count from 0, all right? So sometimes it can be confusing until you get used to it. So again, we're using the variable, square brackets, and putting the index in between those brackets to symbolize that position that we want to get. So before I move any further, we can see a few examples here, and I have a notebook loaded with this given string. This is the first one we have right here. And how can I get the character in position 0? Again, these ones will hold. We don't see them, but they will keep like 0, 1, 2, 3, 4, 5, 6, all these indexes, right? Python is keeping track of each one of these characters with these indexes. So if I want to get the first string, what I will do is s is the name of my variable at, and let's say position 0, right? So that's the first one right there. So I'm gonna do that, just works as expected. The name of your variable will change. You don't need to, of course, use a variable name. I can use my str, right? And just load these one. And now I'm gonna do my str with position 0, right? So you can put pretty much whatever you want. You can actually use the string, right? You can just do these and it's also going to work. Doesn't matter. As long as you have a string here, reference it either directly or with a variable, then you're accessing, right, the character in position 0. One more time, that's how we get it. How do you get the character in position, the character C, sorry, the index of C is index 2. It's actually in the position 3 logically if we talk about first, second ordinals. First, second, third, but actually the index is the index 2 because again we're counting from 0. So here I'm gonna do S at 2, right? And I will get C back. So you can follow this logic with as many characters as you want, right? And whenever you reach the end of your string, there is a property here that happens, that it's that this string has 4 characters, right? But the last one is gonna be 3. So you can follow this rule and the last character in a string will always be the length of that given string, the total length of that string, minus 1. All right, so here what you will end up having is, and in this case is a string in position G. I'm just gonna borrow these for follow example so we can keep them. It's gonna be S at, right, in this case it's gonna be 6. So I'm gonna use 6 first to show it to you. Oh, wrong cell, 6. There you go. But again, this string is gonna have 7 characters, right? If I gave you the length of this string, it's gonna be 7 characters. So 7 minus 1 is gonna be of course 6, right? So I can just use these directly to reference that last character in the string. This kind of looks ugly, right? So there's gonna be a better way to reference these last character. I'm gonna show it to you in a second. The important thing is this general rule, as we're starting to count from 0, the last character is gonna be the length minus 1, right? And here also is that you can put an expression that you want. You can, I've shown you individual integers, right? But you can also put expressions, anything. You can invoke a function, whatever that returns a valid output. So again, there is a better way to access these, and not just this one, all the different characters, but starting to count from the end of the string, right? So here, I'm gonna show you right there. It turns out that I told you a partial story. Python is assigning these indexes to your string, right, without you realizing, but these are not the only indexes that Python is creating. Python is also created, without us realizing, these other strings, indexes right here. All these other indexes are also created by Python. So that means that you can access any of these characters by any of these indexes, the one that you prefer, the one that works better for you at that given moment, right? So if you see the pattern here, we have 0, 1, 2, 3, the ones that we saw before, started to come from 0, and we go up to 3. But the last character in a string is always going to be the character minus 1. And we're subtracting, right? We're going minus 1, minus 2, minus 3, minus 4 from the right to the left, right? So you go from left to right, counting above 0 and 0 included, 0, 1, 2, 3. And from the end, right, from the right to the left, you start with minus 1 and you go minus 1, minus 2, minus 3, minus 4 again. So these are kind of your anchors, you know, these are kind of your fixed positions. You know, there are a few constants for you, and this is great when we're coding. You know that the first character in a string is always going to be the character in the position 0. And we know that the last character in a string will be always the one in position 1. It doesn't matter how many characters we have in that string, that the first one is going to be in position 0 and the last one is going to be in position 1. So here, again, I'm going to show you here, we're going to put the minus sign here. It's going to be actually 7, 6, 5, 4, 3, 2, 1. So the last character is going to have position minus 1, 2. So here I can use minus 2 to reference the G. Or I can also use 6. Again, whatever. Any of these indexes is going to work as intended. So what about the position, the character in position F, for example? It's gonna be, I'm gonna borrow the same code so we can keep it in the screen. It's gonna be also, right, we wanna get the position F, sorry, so this is not good. I can use the character 5, right, that works. So I'm gonna use 5 first, gives me the F, but also I wanna use, the negative index, which is again position 2. So either 2, -2, or 5, it's gonna give me that character F. So now we're gonna talk about string slicing, all right? And it's a really important concept. So now we're gonna start talking about string slicing, and it's also an important topic. String indexing will give you a single character from the string. So we wanted to, for example, get the first character or the last character from a given string. That's possible with string indexing. It turns out that you can also get substrings, right, slices of a given string with this notation, right, and compare it to the previous one. In this case, you were putting just one element between brackets. Here you're putting 2 elements and you're separating them with a column. So you're basically saying, I want to get everything from 0 up to 3. But please look carefully. In this case, the character in position 3 is not included. So what we get from the syntax, and here surrounded with the red square, we see the included characters, is that the result of this expression is going to be all the characters between the position 0 included up to 3 not included. So we could say 3 minus 1. So it's going to go from 0 up to 2 inclusive. All right. This is sometimes counterintuitive, and it will make you it can confuse you, and it's fine. It happens all the time. So what we recommend is just to get a REPL and execute your string slicing to understand if you're doing it correctly. So going back to our examples, right? I'm gonna borrow again this code. I wanna get, for example, from the position 0, which is going to be included. This one is going to be included up to, and I want to get up to ABC. So if I put only these indexes up to 2, I will not include the C. I need to go one further, right? So I'm going to use from. If I want to get this string, I'm going to get all these indexes from 0 up to 3, right? That's going to give me A, B, C. So it's just the last one is never included. A few more examples. First of all, the number at the beginning, in this case 0, it's usually, let's say in a way, we usually start from the first element, right? Position 0 or index 0. So we can avoid it, and by default, these will take the position 0. So either putting the 0 or just leaving it aside, it's going to be the same thing. What you cannot forget is this colon symbol right here. We can also, of course, get subslices starting in aleatory random positions in the string. So for example, here I want to get B, C, D, right? So I start from the character 1, this is included, 1, up to, and I'm going to go C, B, C, D, and I have to select up to this one. So it's B, C, D included. So that gives me up to position 4. So I'm going to put 4 here, and I get B, C, D back. Again, you can also try selecting strings with the length, right? So in this case, the length of this string is going to be 7, right? We have 0 to 6, so we have 7 characters. If we want to get every character starting, or not every character, but from C, for example, or from D up to the end, containing every character after D, we will need to, and I'm going to borrow all the code again, I'm starting with the D position, which is 3, and I go up to 7, right? 7, right there. But of course, 7 is also the length of these strings, so I can make it a little bit more dynamic, regardless of the number of elements. So let's say that we have a new string, a new character here. This method will give me everything from the up to the end of the string, inclusive. If I was using the number 7, I was hard coding it, and I no longer have the character H. So here, this of course is a little bit more dynamic. But actually, it turns out that as we can omit the first character, and by default it's going to be 0, we can also omit the last character or the last element, and by default it's going to take you from that position up to the beginning. So that means you can also do, for example, this, and it will basically create a copy of that given string, which is kind of pointless in this case, but it's also working. So in this case, we're going from 3 up to the end of the string by using the default value of the end of the string. Again, you will need to here, if you want to, for example, get the EF substring, right, you need to get up to H. So here we're gonna go as from 3 up to, and we need in this case 6. So I'm gonna go 3 up to 6, and there you go, I have the EF. Important, string slicing will probably raise errors if you're not careful with the positions. Given this string, right, if I try to access an element that doesn't exist at I don't know, 11, for example, I'm gonna get an index error, right? Indexing getting an error. So you have to be careful with the indexes that you are using. Finally, you have a bunch of examples here to check, right? We have a few negative indexes, we have slices with negative indexes too, and we also have a few examples of step, right? If you want to check further. In this lesson, we're going to talk about string formatting, which is a really important topic because as strings are used all the time, we will want to combine them with some dynamic data. All right, so what do we mean about this? Let's say that you have a service that is going to send an email to each one of the users as they register, right? And you want to include the subject of the email as something like, welcome to our service, for example, welcome, and the name of your user, Mary, or welcome Sean, or welcome, I don't know, Jane, whatever, right? So this is what you want these to be the subject of the email that you will be sending. But of course, this part is dynamic. It depends on the name of the user. You're gonna, at processing time, whenever the user is registering, you will get her or his name, and you will combine that with this static part, right? And we can also make it a little bit more complicated with this way. We want to put also an exclamation mark here, right? And this example follows, right? We will use different types of data. Let's say that you're going to say something like today is, I don't know, Tuesday, January 3, right? Or 2 actually. Something like this. This is also a complicated example because this is going to be a number, and I'm going to show you why in a second. How can I construct this string with the most naive way without string formatting? Well, what I could do is something like print. I could do something like welcome plus, and let's say that I have a variable name with Jane in it, right? So I'm going to do something like welcome. I'm going to need to put a blank space here. It's important to keep spacing right. Welcome name, right? Plus, I'm going to put an exclamation mark. So finally, I have my string built. But this looks ugly, right? I have to just remember about the spaces. I have to understand what I tried to do, etc. Even if I put an integer here following this example, right? This is probably going to break because I cannot concatenate a string, right, with an integer, right? So that's something that's not going to work. That's why we have string formatting. And basically string formatting means putting something like a fixed part of a string combined with dynamic parts of another piece of data, right? So it's gonna be something like this, welcome, and here you're gonna put the user's name, or today is, for example, you can put the day, Tuesday, and something like, I don't know, the month, January, the number, right? 3. So you're gonna put dynamic pieces of data inside your string, and these pieces of data can be of any type, right? And it should work in the same way. So what are the different ways of doing string formatting? And you have all them documented right here. The first one is the one called all style string formatting, and it's gonna use with a percentage symbol. So we're gonna do something like this. You will put percentage symbol and the type of the data you want to output, right? Generally 99% of the time you will use an S. Percentage S is gonna tell you about that this thing right here is a placeholder for some dynamic type. Whenever you want to combine that with that dynamic data you have, name for example Jane again, you will use also this percentage symbol. So you will have here print name subject percentage name, right? And that's gonna give you the final results. You're combining these dynamic piece of data with this fixed string. So if we could separate here, this is gonna be fixed static, this is gonna be fixed static, including the white space, right? Because these things are tricky if we don't use string formatting. And again, every percentage symbol is gonna be the placeholder. Going back to our previous example, I have something like, let's do something like today. It's gonna be today is, I'm gonna put here the day, right? The month, and finally the day, or the day number without further ordinals. So in this case, what I'm gonna do is to finally combine a message. I'm gonna create a new variable here. I'm gonna call it message. It's gonna be today, percentage symbol, and in this case, I need to pass a tuple. So here I will need to pass, for example, today is Tuesday. I'm gonna put January, and here I'm gonna pass 2. And these will work as expected if I don't print anyone. Message, there you go. I will print it, and you will see that the integer didn't cause any trouble. It was just perfectly formatted. Again, these will transform anything back to a string, whatever it is. Behind the scenes, Python is taking your number, right? This is a number 2, the int, the type, of x is gonna be int, and it's gonna do str of that number internally again, and it's gonna transform it back to a string, right? So this method will work for any use case. So again, this is the old style of formatting. How do you realize that it's the old style? Because you see the percentage symbols all around. Placeholders, percentage S, and whenever you want to build the string, you will use percentage plus a tuple. So let me tell you right now, I'm sorry, but this is not the recommended way. There is a new way of formatting, a new style of formatting that is gonna use something similar, but it's gonna change a little bit. So first of all, the way you will express the placeholders will be, instead of percentage S, you will put here curly braces, opening and closing curly braces, like a placeholder, like a blank space. This thing needs to be filled with some dynamic data. And how you're gonna combine that with your dynamic data, you don't need a percentage symbol. What you will do is get the original template string, we can call this one a template, and do dot format with that given name. In this case, what is going to happen is that you will not use this operator anymore. You're using actually a string method. That's the big difference. So if I show you this first example, and I can comment out all these, there you go. It works pretty much in the same way. It's the new style, and we're going to see a few reasons why this one is the preferred one. So in our previous example, if I want to do the same thing as before, I need to use placeholders for these ones, right here and also here. And again, instead of using the percentage symbol, I will just use dot format, right? And I will just pass all the parameters, right, to the dot format method. And I forgot to print it again. There you go. We have today is Tuesday, January 2, right? It's important again to emphasize this part that this is an integer and is converted back to a string. So why is the format method the preferred way, this new style the preferred way? Well, actually, and you have more details here, because this will allow you for better readability. Let's say that this example is super simple. You have only one replacement, so maybe it's not that useful to know what should be here. You know, it's pretty obvious that by reading this code, it's going to be something like the name, etc. But in this case, it can be a little bit confusing. We have just 3 curly braces or placeholders. So what I'm going to do is assign names to these placeholders. I'm going to do something like the day. It's going to be the month, and this is going to be the number, the day number I'm going to put. Right? So you can assign names to each one of these placeholders. So then when you're creating the actual formatting, you can express those names. So you can say day is equals to Tuesday, and you can say month is equals to January, and finally day number is going to be equals to 2. So I want you here to understand that these two things can live in separate places. You're never, not never, but usually you will not have both the template and the actual usage in the same file, one line after the other. This is probably living in a separate file or in a different library or even a different module. So it's hard for you when you're using it to understand, or when you're reading the code, to understand what each one of these things meant. So in this case, by providing these names, you're giving a little bit more readability to your code. You will also see that this new string formatting has a few other advantages. For example, aligning data. So in this case, we can align something like, I'm gonna get a message here, something like a word. I'm gonna get it right here. I'm gonna print this value. There you go. And you can align things to given places, right? Or you can align everything to the right, which is pretty much the same thing as saying we're left padding the string, right? So I can align everything to the left, and I will have a wrong variable name. So I can put everything to the left. And we have these quotes here on purpose, so you can see the entire string. So everything else is gonna be filled with blank spaces. Or we can align everything to the center, right? Just using this character, we can align everything back to the center. And you can also provide that given character that you want it to be used to align things. So in this case, right, I'm aligning things to the center, but the characters used for padding, the character used is not a white space, gonna be this symbol that it has just provided, and I can put any symbol that I want. Of course, that if this number is if this string has less characters than the one you requested, right, it will not be padded, right? It will be just showing the total number of elements that you had. This formatting is incredibly useful for numbers, right? Especially for numbers with decimal values. So in this case, we have this number that has decimal values, and let's say you are working with a simple app and you don't want to show all these numbers to your user, right? So you can, for example, show up to, I don't know, two decimals. So what I'm going to do is this, and this will show you just 2 decimals. On top of that, we're also given the total number of numbers that we want to show at the beginning of the string, which of course doesn't affect if this number has too many at the beginning, right? So this will still show the whole thing. What we're doing is, again, we're kind of left padding that given number with these with zeros, right? So how you read these is you want 6 characters in total, right? If, of course, this number doesn't have too many digits. If it has too many digits, it's gonna just respect that. So if you don't have that many, you want 6 total, right? And you want top 2 decimals, right? At the right decimal, right? The right position. So here you're gonna have these 3 numbers plus the decimal plus the dot, and that's gonna give you the 6 characters out. Right, so you can keep practicing with string formatting. You can also, of course, give names. So let me show you just this example right here. You can put before the colon, right here, before the colon, and I can put it side by side. You can give it a name, right? So now we're using pretty much the same formatting, but we're using a name for that. So this is about string formatting. It's an interesting topic. There are too many things to see, to be honest, but it's super powerful. Remember that the new style of formatting is the one recommended. We sometimes, from time to time, use the O1 because it's sometimes shorter. But it's just, you will see it for a few examples here and there, nothing for real code. Usually in our code, we kind of enforce using the new style string formatting. And one more thing, check the versions you can use each one of these. This formatting was thought initially for Python 2, but it was ported to Python 2.7. It was thought initially for Python 3. And it was backported to Python 2.7, so you can use it in Python 2.7 and Python 3, but given the chance, the remote possibility that you're using Python 2.6, you will not be able to use this new style formatting, and you will need to use the old one. And again, the recommended this one because it's a little bit more powerful. There are a few things that you cannot just do with the old style. For example, the right center function, you cannot do this with the old style formatting. It's only available for the new one. Again, it's a little bit more powerful. So the objective of this lesson is to show you how to iterate over strings. For that, we will be using a wide variety of techniques, but the most important one and the recommended one will be the usage of for loops. But before that, we need to see what's the reasoning behind them. So in this case, we start with a simple string A, B, C, D. From the indexing lesson, you know that each one of these characters has a numeric position assigned, right? I'm omitting the -1. And if I want to print each one of the characters of this string, I could use a really manual method, right? A, B, C, D. And I'm just lowering them to show you something else. I want to not just print each one of the characters, I also want to lower them before printing them. So I am performing again a super manual task. I'm getting each one of the characters with a given index, manually creating each one of these, and finally, right, executing the code. If I have one more character, for example, this code no longer works. I mean, no longer works in terms that I'm not printing each one and every character in the string. I'm just printing A, B, C, D. I need to create one new of these two lines, right? One block of these two lines to get this new character working. So we know that this is not a correct approach. Something else we can do in this case is do something like this. Keep an index variable outside, and now each one of these blocks becomes pretty much the same thing as the previous one, right? If we add a new string, we still need to add one of these blocks at the bottom, but we are closer to having something a little bit more scalable. We are just creating each one of these blocks, right, to print one of the strings, but they are all looking the same. So remember, if I could use something like repeat, right, a given number of times, this thing, I am pretty much done. Of course, we don't have the repeat block. What we have is the while block. So here, what I will be doing is something like while the index is less than what? Right? I have 0, 1, 2, 3, 4 characters. The index should always be less than 5, right? While the index is less than 5, I want to access that given element, right? Print it as a lowercase, and finally increase the index for the next one, right? So I have all my indexes, all my elements printed. If I want to make it a little bit dynamic, regardless of the length of the string, I could use the length of the string, because again, I go from 0 to 4 because I have five characters. If I have 6 characters, right, I go from 0 up to 5. So here I can do len of that given string. So here I have the real dynamic block to access each one of the elements. If you stop for a second and you think all the different pieces of code that you had to assemble in order to get to this final solution, there is one that it's the one containing the actual business logic, I'm gonna say, that you wanted to do. In this case, printing the character as a lowercase letter. Let's say that This is a super simple example, printing it lower, but you're processing a given string and you want to check if a given special symbol is present, So this is business logic. This is what you want to do. Everything else is going to be boilerplate. Creating an index, creating the while loop, accessing the given element, incrementing the index. This is not business logic. This is boilerplate code that we're creating to support our business logic. So of course you can imagine that that's bad. On top of that, there are two more things that I like to get rid of. The first one is the need of creating this condition. I have to carefully think about the condition. What's the upper limit? Should it go up to 5? Should it go up to 6? Should it go to length or something? What if I want to check half of the string? So this thing, thinking about this condition is first time consuming, and second, I can always miss. I can always create the wrong upper limit and my code is not working as expected, right? And on top of that, what happens if we forget this one? Remember, we end up in an infinite loop. And this is of course really bad. We try not to stay away from infinite loops. So this is also bad. And this can happen. I mean, you can forget this final statement. You can be rushed because you're close to a deadline. You can, maybe you're close to lunch and you cannot think about anything else but food because you're super hungry and your brain is not working. These things happen. If you're working as a developer professionally 8 hours per day, at some point you will face one of these bugs. And this is a pretty nasty one. We should try to stay away from infinite loops. So again, this is something that can happen and we need a better way. The better way in this case is gonna be the usage of for loops that are pretty much the same thing as these while loops, but they will have a little bit more of simplicity. These for loops kind of work on top of the while loops without us realizing that. A for loop is intended to actually loop over each one of these elements in a given collection. For now we're using strings, but you will see that these will also be useful for other types of collections. So the idea is that the for loop will assign each one of these characters to this variable you're creating, intermediate variable, and you will be able to use that variable in a traditional Python block of code. So here I can just do lower as before, and I have pretty much the same example as before, or the same outcome, the same end result as before, but I want you to compare these two lines of code. Right? In this case, I need to create the index, I need to think about the condition, I need to access the individual element, and I need to be extra sure about not forgetting to increment the index. 1, 2, 3, 4 lines extra. In this case, the only thing that I do is I declare that I want to iterate over this my string by using this C character, right, as the intermediate one. So each one of these characters here will be assigned to this C variable right here, and I will be able to use that variable here. Of course that I could call this thing my character, I can call it whatever I want. I'm using C for simplicity. And that's because I want to show you a graphical representation of this for loop. So here we're in our drawing tool, and what we have is pretty much the same thing as before. We have our given string, as you know it, and we will start this for loop. And I want you to see how we're looping over this. Here I'm gonna use two things. Every time I print something, right, that print statement is gonna go here. That's the output of my program, pretty much whatever is shown in the console. And then I'm gonna show you some debugging info. I'm gonna put some debugging info here for us to track variables. All right, so we start executing this Python code, top to bottom. We get this one right here, we know the my string. And internally, again, we wanna go over each one of these characters. So I'm gonna keep like a secret index variable that is gonna keep pointing to each one of these. It's not actually created. I'm gonna call it _index. It's not actually created, but for us, for now, it's just gonna work that way. Then we're gonna start the execution of the for loop, and this is where the magic happens and what we wanna focus on. So when this thing starts, Python assigns the character C, or the variable C, sorry, to the first character in your string, right here, to the character A. Actually, it's gonna be right here. So here I'm gonna also put the character C. The variable C is gonna be pointing to the character A, right? So that's the first thing that Python reaches this line. So now what you will do is it's gonna drop you inside this body and it's gonna execute this body for C being, in this case, A, right? So for as long as this body lasts, this value of C is gonna be A. So here we're just gonna printing it, right? So we just direct output here, I'm gonna print the character A. We're printing C. What's contained inside C? It's A, so we end up printing A. So now this Python for loop has reached the end. The same thing has happened with the while loop. Once it reaches the end, it's gonna go up again and it's going to ask a question in order to realize or to know if it should keep iterating or not. The question that the for loop is gonna ask is, are there still characters remaining in this string? As simple as that. So as long as there are characters remaining, it will keep looping. So once it has reached the top again, it's gonna advance now this pointer right here. This one is gonna be erased, whoop, right here, and it's gonna create a new one right here. So it's gonna advance here. So now, and if we have positions here, 0, 1, 2, and 3, index was before it was in 0, and now it's gonna be in the position 1. And now the character variable, the C variable, this one will be equals to, I'm gonna just cross this one, it's gonna be equals to B, right? And now it's gonna execute this whole body again, right? And again, for the lifetime of this particular body, now C is bound to B. So when we do print the variable C, it's actually holding the character B. So here we print, right, B. So Python, I'm gonna put the B here. Python reached the end of the body again. I've said this before, you can have as many lines as you want. It's gonna go back again to the beginning. It's gonna ask how many are there still remaining characters, and there are. So here's gonna advance all these pointers. This is all kind of bookkeeping task. We don't see it, that's the beauty of it. So here it's gonna put, the pointer is gonna be here. So now the index is gonna be advanced back to the position 2. Again, remember we don't see this, it's just internal. And now we don't have B anymore, we have C. So now it's gonna be confusing because the variable is called C and the character is also called C. So here again, the whole body is executed. We print the variable C that contains actually the character C, right? So we have here C. And Python gets to the end, goes back again to the beginning. So now it's gonna advance this pointer again. So it's gonna do this thing is erased. And it's gonna add the pointer here. And C is no longer working here. So now it's gonna be D, and the internal index gonna be 3. So we execute the body once again with the C variable pointing to the character D. We print the, right, these are output. And now we have reached the end of the for loop. And whenever Python, it goes back again, let me remove this, it goes back again to the top. And now there are no more characters to keep iterating over, right? This is done. So now Python immediately realizes that and just automatically stops and keep executing your code as you want. So takeaway from this is that these two blocks, this thing and this thing, they work in the same way, right? So it's important to understand the simplicity of this block. We don't want to use these type of things. We don't want to manually access the characters by positions, all right? So this is a really important takeaway of this lesson. We don't want to see you using this style. We want you to use always the for loop style because it's much cleaner and safer. Remember that these can give you troubles later. So again, if you want to iterate over a string, what you will need to use is a for loop instead of a while loop. And before I finish, I'm gonna show you pretty much the same thing but with Python tutor. as usual, right? So we're going to use this code again. So you can see how the variables are set, and Python tutor is also keeping debugging information here, and it's also keeping the output at the top. So here what's going to happen is that we only have myString equals to this, right? Because we have just executed this line. And now when I start this for loop, right? Next line to execute is the right one. When I start this thing, the C variable, you see it's bound to the character A. We print that code, and then the Python code goes back again to the beginning, right? So we print it out and goes back again to the beginning. And when we execute that line again, now C, the variable C is now pointing to B. I want to do that once again. We start C is equals to A, we print the result, we advance that one again, and now C is pointing to B. We print that, and I want you to keep your eyes here. I'm going to advance the pointer again, and you see how C is just automatically changed to the character C, right? So that keeps moving forward until at some point Python realizes that there are no more characters, and the Python script just finishes. So important takeaway, this C variable is going to be bound to each one of the characters in order, right? It's going to give you the chance to process each one of the characters, right, in order, binding that character to the variable C. So then we have the question. We showed you first the while loop, then we showed you how to kind of use a hack with the while loop to iterate over a string, accessing each one of the individual characters. Finally, we told you not to do that, and please always use for loops instead. So the question is, when should we use a while loop? And generally the answer is simple. You will use a for loop pretty much 99% of the time. For loops are the main looping construct of Python. You will see them working in other collections types, etc. But there are a few use cases for while loops, and those use cases include those times when you don't know how many times you will be looping. And here it's important to understand what I mean by you don't know how many times you will be looping. It's basically something that it's out of your control. You will be looping a given number of times, which is out of your control. And a good example of that is creating a password for a given user. So you have a user that wants to generate a new password, right? So I'm going to show you this piece of code working first. There you go. So we have a given condition for this password to be valid. The first one is that the password should have more than 8 characters, first thing, and also it should include the dollar sign, the dollar symbol. If those conditions are not met, the password isn't valid. So for example, a short password will not cut it, a short password with the dollar symbol will not cut it, and a longer password but without the dollar symbol will not cut it. So something like a long password with the dollar symbol there at the end, it's gonna work as expected. So for this, I'm putting a while loop. I'm keeping this valid variable, so I'm doing something like while the password is not valid, basically, and this reads well, I'm going to ask a user for a password at the beginning. So I'm assuming, it is an important thing of while loops. I'm going to ask the user for a password, and I'm assuming right at the beginning that it's not valid. If I reach this line and the password is valid, I will just assign valid to true. The while loop's gonna go back again to the beginning, and now this condition will no longer work because it's not valid. We're gonna talk more about this in operators. And then it's gonna all execute back and just put this one at the end. So let's say that the first time I put a valid password, so a bunch of characters plus the dollar symbol at the end. There you go. This while loop looks like it was never executed. It was actually once executed. We got this line didn't execute because the password met all these criteria. So it jumped directly to this valid equals true. It turned valid, it flipped the value of valid, and then it went back again to the beginning, and as this condition is no longer true, it just jumps back here. All right, so this is a good example of that I told you, that we don't know how many times we're gonna loop because it doesn't depend on us. We don't know if the user is gonna create a valid password in the first time, or it's gonna take 5 times to get a valid password. We don't know it. We cannot possibly know it in our code. So that's why that's a good example of a while loop. Something different is, for example, you're checking, for example, an external service, right? So you have a sensor somewhere in your home that is checking if the sun has already risen, right? So you're checking that for a given number of times, and you're sleeping 1 second, right, between check and check, right? So you check if the sun is out, and if that's not the case, you sleep for 1 second, and you keep repeating this cycle. The moment that the sun rises, right, this will break, and you will call this line. So you don't know when that's going to happen, so you need to use a while loop. For everything else, you will be using a for loop, even if you, let me comment out these lines, even if you don't know, for example, let's say that you are asking the user for a given password, and you want to print all the characters of that password, right? In this case, we don't know if the user, we don't know if the user is going to put, I don't know, 1, 2, 3, right? Or it's going to put more characters, like all these characters. So you might be tempted to say, I don't know how many times I will need to loop. Well, you don't know as a programmer, but Python is really capable of answering the question right here. If I do this, the length of the password, I know how many characters it has, right? 7. So before my loop here, I know how many times I will end up looping. So this 4 character in password, this is a great example of a for loop. We might think that we don't know how many times we're gonna loop, but actually at runtime, in this precise moment here, we are able to answer that question. This password has 15 characters, whatever. So we know that. That's why this is a good case for a for loop. As a general rule, again, every time you need to iterate over characters in a string, or elements in lists and collections, you will see that later, a for loop is gonna be the one used. And finally, to say this once again, you will use for loops pretty much all the time. 95% of the times you will be using a for loop. So it's to start thinking about a for loop is gonna be the safe bet in this case. With this lesson, we're opening the unit about collections. Collections is a really important topic in programming in general, because you will find collections to be used across any programming language. So why do we need collections in the first time? Well, because we will start using individual elements, like in this case, I'm holding usernames, as you can see right here. But at some point you will want to have a way to group them, right? A container to keep all these elements, all these objects, right, but in a dynamic way. If I'm keeping each one of these usernames in an individual variable, there is no way that I can dynamically change these values, right? So let's say that I have these, it's a website and I'm registering a new user, so I want to add that new user's username in my program. There is no way for me to do that, because I would have to stop the program and put then the username in a variable, right? As you will see, collections will be these dynamic containers, right, that will be able to hold as many values as you want. 0 values, 1 value, n values, they will all be kept in the collection. You will find that there are different types of collections, and we're gonna talk about them in detail. And more importantly, we're gonna tell you what are these traits that will make them different from other collections. And we want you to focus on those conceptual differences, because first, you will be able to transfer that knowledge to other programming languages later if you ever need so, right? They are fundamental or conceptual traits for each one of the collections.
And more importantly, it will let you judge on the side which is the correct collection whenever you're trying to solve a problem. So you're writing some code to solve a particular problem, and you will usually be faced with this question of which collection type should I use? And the bad news is that usually any type of collection can be used to perform a given task or to solve a given problem. But some collections will be just fitting better, right, for that particular domain. Sometimes they're going to be more performant, right? They will run faster, or they will save in memory, or they will just be better at the moment of reading the code and extending it and understanding it, right? So different type of collections will give you different benefits depending the type of problem that you're solving. And being able to judge this on your own, it's a really important trait for any programmer.